Hello everybody and welcome back. We're going to finish off the 2006 Fryer paper in this video by looking at question number 4. Alright, so 4's got 3 parts to it. A. How many of the positive integers from 1 to 100 inclusive do not contain the digit 7? Okay. Well, I know basically each group of 10, so 1 up to 10, 11 up to... Actually, no. 1 up to 9 has 1 7. 10 up to 19 has 1 7. 20 up to 29 has 1 7. Other than the 70s, which we can discount entirely. So it's got 1 7. Ten to 19 has 1 7, namely 17. 20 to 29 has 1 7, so that's 27 right there. 30 to 39 has 1 7 in the form of 37. 40 to 49, 50 to 59, 60 to 69, 70 to 79 has 10 sevens, namely 70 all the way up to 79. We'll fill this in a little bit more, and then we'll get back to the 80s. Alright. 80 to 89 has exactly 1 7. 87. And what do we get? 90 to 99. The only standout there is 97. That's 1 in that range with 7. So it's got 0 of them with 7. Okay. So now we need to figure out, well, how many numbers are in these ranges? So 9 in total from 1 to 9, minus 1. 10 of them, minus 1. 10 numbers from 20 to 29, minus 1. 10 minus 1, 10 minus 1, 10 minus 1, 10 minus 1. This one, there's 10 numbers, but all 10 of them contain at least 1 7. 10 minus 1, 10 minus 1, and lastly, 1 number minus 0. So that's 8 plus 9, plus 9, plus 9. Let's make sure I'm not skipping. So there's going to be the 1s, the 10s, the 20s, the 30s, the 40s, the 50s, the 60s, the 80s, and the 90s. That's 8 of them have 9 numbers that don't contain 7s. So that's 72, plus 1 for 100, plus 8 for 1, 2, 3, 4, 5, 6, 8, 9. And that's going to give us a total answer of 81. So we have 81 numbers that have absolutely no 7s in them. Okay. Does this make sense? Well, we got rid of 10 out of the total 100 right here, and then the 0s, the 1s, the 20s, the 30s, the 40s, the 50s, the 60s, the 70s, and the 80s all got rid of 1. So that's 9 1s that we dropped. So minus 10 and then minus 9 individual 1s, that's 100 minus 19, 81. So this answer does make sense. So 81 numbers have no 7. So that gives us A part. Nice start to the question. B. How many of the positive integers from 1 to 2,000 inclusive do not contain the digit 7? Okay, so we're just asked to do this on a grander scale. We could probably take what we learned in part A and recognize patterns. So what could we do? Well, in A, we went from the numbers 1 to 100 inclusive, and we figured out there were 81 of them that contained a 7. There were a bunch of the 2-digit ones that contained a 7. So, one might say, other than the 700s and 1700s, no range of hundreds will have 7s anywhere but the 10s and 1s digits. Okay. So by part A, in any range of 100, exactly 81 numbers do not contain a 7. Okay. So 1 to 100, 81 numbers. 101 to 200, we can say 81 numbers don't contain a 7. None of the leading ones are going to cause us any problems, so it's still up to the 10s and the 1s digits. Okay, 201 to 300, that's 81. 301 to 400, 401 to 500. We're getting close to the 700s, however. 601 to 700. So that would be 81 there. But it's minus 1 for the 700. So 701 to 800. We just get one, namely 800 by himself is the only number in this range that doesn't contain a 7. All of the other ones have a leading 7. Now we're back to 81 of them. Oh, no, we're not at the thousands yet. 901. So 901 to 1,000. Still not going to have any leading 7s in or 7s in the hundreds or thousands places. So it's always still up to the 2-digit numbers at this point. Until we hit 1700, which we'll have to do on the next page. Let's tally up what we have on this page right now. So 81 plus 81 plus 81. I can really just count them all up. There's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 81s. Minus 1 for 700. plus 1 for 800. So that's going to be 972. On the previous page, and we left off, I believe, we just got to 1300. Yep. So 1301 to 1400. Still 81 numbers with no 7. 1401 to 1500, that's 81. We're getting close to 1700, however. So we had to subtract off 1 for 1700. He's different. He doesn't have his 7s in the tens or units place. He has them in the hundreds. 1701 to 1800, the whole thing's a write-off. Except for that 1800 at the end. 1801 to 1900, that's still 81 numbers. And we were asked to go up to 2000, so that's another 81 numbers to finish us off. So 81 plus 81 plus 81 plus 80 plus 1 plus 81 plus 81, 486. $972 plus 486. That's going to be equal to 1458. So 1458 numbers with no 7. Does this make sense to us? Well, the 1700s, and so we start with 2000 numbers, the 1700s and the 700s, that knocks off 200 right away. So already we're down to 1800. And of those, we had 81 each time. So this should likely be 81% of 1800. And indeed it is, so that makes sense to us. I mean, there might be one or two fiddly little cases that we forgot to account for, and we could go back and review and double check that our method works, but we want to press on, so we're reasonably confident in our answer of 1458. Alright. It's always best to show some work, get an answer, and then after you've done as much as you can, go back and double check things. Alright. So C part, the last question on the contest. Determine the sum of all the positive integers from 1 to 2006 inclusive that do not contain the digit 7. Explain how you got your answer. Okay. What should we do? Well, the way we answered B was we took a look at A, which dealt with the numbers 1 to 100, and we just applied that over and over again to get the numbers from 1 to 2000, but we sort of segmented them into ranges of hundreds. So it might be a good idea to figure out the sum of all the positive integers from 1 to 100 that don't contain a 7, and repeat that process over and over again. So let me show you what I mean. So suppose capital S is the sum of numbers from 1 to 100 not containing a 7. Well, then 81 times n times 100 plus s is the sum of the numbers from n minus 1, 100 plus 1 to n times 100 to n plus 1 times 100 not containing a 7, for the most part. Okay, this isn't going to work for the range where n is 1700. We're just going to have a little 1800 here. It's not going to work for n is 16, because we'll have to subtract off that 1700, but it's a good start. Better thing to do, I think, is to not do 1 to 100, but from 0 to 99. Although, do we still get 81 of these? No, I guess 1 to 100 will have to do, and we'll have to augment it as we go along. Alright. I was going to change it to 0 to 99 so that all the 1700s would be grouped together and all the 700s would be grouped together, and that would be much easier to deal with, but I'm worried that this 81, the 81 definitely comes from, there are 81 numbers in the range 1401 to 1501 not containing a 7, and that they're all the same as the ones in the previous range, we just added 100 to them. Okay, so we're going to have to leave that 81 there, and that means that our range is definitely going to be from 1801 to 1900, or 1401 to 1500, or 601 to 700, that sort of stuff. Okay. So, from A, it is not hard to see, we get the ranges 1 to 9, so S is 1 to 100, minus 7, minus 17, minus 27, minus 67, minus 87, minus 97, minus 70, 71, 79. So the 70s and then all the other ones that just have a single 7 digit. Well, the sum of the numbers 1 to 100, that's 100 times 101 over 2. I've done a video on the sum of the natural numbers, so you can take a look at that. So we're just doing shorthand here. Sum of the numbers 1 to 100 is 5050. It's a fairly common thing to work out. So S is 550 minus 7 minus 17 all the way up to minus 79. So 5050 minus 7 minus 17 minus 27 minus 37 minus 47 minus 57 minus 67 minus 87 minus 97. That's going to be 4607 minus, and then we need the 70s, 71, 72. So now if we subtract off 70, 71, 72, 73, 74, 75, 76, 77, 78, I think we get 3,862. Let's just double check that by adding back in all those numbers. So bear with me for a moment. I just want to check before I start using this number a whole lot. Alright, so this appears to be the right number. Okay. So 1 to 100, we get a sum of 38620. 101 to 200, we get 3862 plus 81 times 100. So our formula says 3862 plus 81 times 200. 301 to 400, 3862 plus 81 times 300. Okay, we can keep going on like this. You could probably figure out a pattern if you wanted to make it a little clearer, but because we're going to have to work out little workarounds when 700 enters the picture, I think it's best to keep it in this little chart form. That way we know what we're doing at each step. So here we go, 601 to 700. Well, that's going to be 362 plus 81 times 600. But we're going to have to subtract off the 700 that we're adding here. Okay, 701 to 800. Well, we wouldn't add up any of these except 800 by himself. Okay. 801 to 900. 3862 plus 81 times 800. 901, 1001, 1101, 1201, 1301. I just want to see if I have to be on the next page again. 1601, 1701. Yep, I'm going to have to go on to the next page. So let's mindlessly fill out this little chart. We'll keep track of everything on the right-hand side, but we'll get to filling that out in a moment. All right. So 3862 plus 81 times 900. 3862 plus 81 times 1000. 81 times 1100. 3862 plus 81 times 1200. 3862. That's why I wanted this number to really be double checked before I started using it a whole lot. All right. So we'll just have the up to 2000s on the next one, and then we can't forget we have 2001, 2002, 2003, 2004, 2005, and 2006 that we need to add up to. Remember, we were doing the numbers 1 to 2006, because that's the year of the contest. So let's work this out. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 copies of 3862. We have 81 times 0 plus. You know what? Probably I want more space. I definitely want more space. It's going to involve flipping back and forth in this little scrapbook, so I do apologize, but I want more space to write out what I've got. So 17 copies of 3862 plus 8100 really times 0 plus 1 plus 2 plus all the way up to plus, I think we're at 1800. Oh, no, that should be 1800, not 1900. Always good to double check things. All right, but we'll be omitting the 700s and the 1700s. And then we subtract 700, add on 800, subtract 1700, add on 1800. We get no 7 or 17 here. Right? No plus 81 1700, and we have no plus 81 times 700s. Alright, so 3862 times 17, that's 65,654, minus 700, plus 800, minus 1700, plus 1800. So we get 65854. So 65854 plus 8100 times the sum of the numbers 1 to 18. So 18 times 18 plus 1 over 2, minus 7, minus 17. So 18 times 19 divided by 2. So 171 is the sum of the numbers from 1 to 18. We subtract off 7, we subtract off 17. We have 147. We multiply that by 8100. We get, what is that? 11,190,700. And if we add those two together, we get 12, 5, 6, 5, 5, 4. Yep. Alright, so that's the sum of the numbers on the previous page. I admit it's a lengthy, ugly process. One might call this question a tad inelegant, but one might be reacting prematurely. There's probably a much simpler, quicker way to do this. But based on the way we handled A and B, this is the method I'm choosing to go for. If there's a nice, quick, elegant solution, it will likely be presented in the online solutions that Waterloo provides, and you can find that in a link down below. But just because you don't think you're doing a question properly is no reason to believe that there isn't a nice solution out there. That's arrogance, and that's not something that is really welcome in mathematics. So we have 1,256,554 from the previous page. Where did we leave off? We have to do 1,901 up to 2,000. So that's 3862 plus 81 times 1,900. And 2001 up to 2006. Let's just double check that that's actually what the question was asking for. Right, up to 2006 inclusive. So the nice thing is that 2001 up to 2006, none of those have the number 7 in them. And we can easily work out that sum. And that's 12,021. 6 copies of 2,000, and then the sum of the numbers 1 to 6. That's 21 plus 6 times 2,000. 12,021. All right. So we need to add all this up. So 1, 2, 5, 6, 5. 5, 4 plus 12,021 plus 3862 plus 8100 times 19. Just rearranging that. 8100 times 19. That's going to be 15. Oh, geez, that's a big number. So we get 12,565.54 plus 12,021 plus 3862. The last 3862 we'll ever need. And then 153,900. All right. And now we just have to add these up. Thank goodness we have calculators. They do make this work go a little quicker, although you do have to be very careful that you are entering in the right numbers. So if you are absent-mindedly punching digits, you might be entering in the wrong values. So in total, I believe we have 1,426,337. All right. So that's what I'm saying the final answer is. All right, does this at least make sense to us? Well, what's the sum of the numbers from 1 to 2006? That's 2006 times 2006 plus 1 divided by 2. So that's 2,013,021. So that's at least making a little bit of sense. And we should have, I don't know, I guess roughly 81% of that should be the number that we're talking about. So roughly 81% is 1.6 million. Okay. So can we refine that a little bit better? So I'm going to say that's our final answer, but I'm also going to sort of double check it in a sense. Let's subtract off the numbers from 700 to 799 inclusive. And the number is 1,700 to 1,799. All right, so I get an answer that's roughly similar to this. Obviously, you get in with the little nitpicky. There's specifically 81 numbers that we're trying to add up in each group of 100, so it's not going to be entirely exact, but it's still close. And I'm actually going to end the video and go double check to make sure this number is correct, and I'll leave a comment if it isn't and where I went wrong, and maybe I'll make another video correcting myself. But other than that, I mean, there's really not a whole lot else that can be said. I'm just double checking my sum again because it's a really lengthy sum question, and that's That's always error prone. Always, always, always. But yeah, so this is the final answer we're going with. Certainly an inelegant way on my part to handle C, but it's what jumped out at me from A and B. So I'm not going to belabor it. I've actually probably wasted the last 5 minutes just entering buttons on my calculator and not talking. And that's me trying to get a handle on whether or not my final number was correct. Because really, this was one big, very fiddly sum. And I do apologize for the way I handled it. I'd like to see if there's a more elegant solution provided online by Waterloo. And that's what I'm going to go do. So whatever way it turns out, that's a 2006 Fryer. I think we got the right answer. Again, I will post a correction in the description for the video if I am wrong. But I don't think so. I think we did tackle it methodically. It's just a really big, awkward sum. So thanks for watching. That's the 2006 Fryer, and hopefully when we do the 2007 Fryer, it's not as calculator intensive at the end. So thanks for watching, and I'll see you guys next time.